It's T-minus 4 days before we launch a new technology that will expand our view of our solar system and beyond. The Nancy Grace Roman Space Telescope. This is About Space Today's special report, and I'm David Denault. Thanks for joining me today to share an amazing story. Before we get into what this new technology will mean for planetary scientists, how about the woman who has been named the mother of Hubble Space Telescope? Her name is Nancy Grace Roman.
Well, I think science is very important in today's society. Much of our modern life depends on science and the background that science gives to engineering. The engineer is trying to find out how. The scientist needs to find out why. But we wouldn't have cell phones. We wouldn't even have refrigerators without basic science. My name is Nancy Grace Roman, and I'm known as the mother of the Hubble. I have no idea how I became interested in astronomy. Most children are interested in astronomy between the ages of 10 and 12, and I never outgrew it. I wanted to know what stars were like, how they behaved, and what astronomy was all about. In my junior year, I went to my high school guidance teacher and asked for permission to take a second year of algebra instead of a fifth year of Latin. She looked down her nose at me and sneered. What lady would take mathematics instead of Latin? And that was a general attitude towards women going into science. In spite of that, I made up my mind in 7th grade that I was going to be an astronomer. It was about 6 months after NASA was formed that I was asked to set up the program in space astronomy. Or really, I was not asked. I was asked if I knew anybody who would do it. I took that as an indication that they were asking me. And that was more than 50 years ago, and I think that parts of my program are still influencing astronomy. One of the ways that astronomers study objects is to spread the light out into a rainbow. And that rainbow has lines which tell you what the object was made of, how hot it is, how dense it is. And it also tells you how fast the object is moving towards you or away from you. That was the main reason for the Hubble and why it was called the Hubble. However, it was used for an awful lot of different purposes. It was used to study the planets, and particularly Jupiter and Saturn. It was used to study very distant objects, such as galaxies, and it was used for studying almost everything in between. For the first 17 years I worked at NASA, I found out later that I was the highest woman in the organization. After that, NASA really made a major effort to hire women and in senior positions. I'm not sure how I feel about being called the mother of the Hubble. I feel somewhat uncomfortable about it, I have to admit. I feel it's an honor, and I'm not sure it isn't justified. On the other hand, there were a lot of other people involved in getting the Hubble up and working also. I will be remembered for the Hubble, I'm sure, but I guess I would rather be remembered as a successful person and as a good human being.
And I want to invite you to watch our live coverage from the Kennedy Space Center's press site. My guest and co-host will be the University of Central Florida's planetary scientist, Dr. Ryan Orley.
I was interested in space since I was a child. I was a child of the late 1980s, so this was the time when Voyager was visiting the outer planets, and so all of those spectacular images came back. So like other kids in that era, I was really compelled by those images to study space. I study rocks from space of various forms, and that's kind of the umbrella that defines a lot of my research. Those can be natural samples that we get as meteorites here on Earth, or they can be actual samples that we send people, in the case of the moon, to bring back to Earth, or more generally, robots out to the asteroids and comets and other worlds in our solar system and bring those materials back to Earth to study.
And what makes this space telescope so different?
What are dark matter and dark energy? How common are planetary arrangements like our own? And how many planets in our galaxy have the potential to harbor life? The Nancy Grace Roman Space Telescope will help answer these fundamental questions. Each image from its wide-field instrument will have the depth and clarity of Hubble's best, but capture a sky area 100 times larger. The Roman Space Telescope will take the lead in exploring dark energy and dark matter. We only know they exist by their effects on observable matter, yet these two mysterious components make up 95% of the universe. The Roman Space Telescope's powerful 2.4-meter mirror, an enormous field of view, will also help us in the search for planets beyond our solar system, or exoplanets. To deepen its study of exoplanets, the Roman Space Telescope will house a beyond state-of-the-art coronagraph that will directly image and analyze Neptune-sized planets in orbits slightly larger than Earth's, a dramatic improvement over current capabilities. The Nancy Grace Roman Space Telescope will help us answer many of the biggest cosmic questions. Roman will be an indispensable part of space science during the next decade and beyond.
What makes this space telescope so different? Well, during a NASA news conference, I was able to ask the panel a question. And first to respond is Jeremy Perkins, Roman's integration and test scientist.
But we will go next to David Denault with About Space Today. You can go ahead, David.
Well, AST, our About Space Today, has an older age demographic. So in layman's language, how will the Roman Space Telescope benefit all mankind? A question for each of you from your positions.
So I think the main thing is something I've already talked about. I think that the data set that Roman is going to produce is something that will not just benefit the science teams that are thinking about how to use it now, but they're going to be a benefit to the students in 5, 10, and even 20 years. Folks are going to be looking through this data for answers that they can find with Roman's data that they just don't know about today, that we haven't planned to use the observatory for. So that's kind of what I'm really excited about, the legacy of the data set that we're producing.
Next to respond to my question are Julie McHenry, Roman's senior project scientist, followed by Jackie Townsend, Roman's project manager.
I'm ancient, so I may be in your demographic. I've been here long enough that I watched Hubble's findings change our understanding of the universe and change the textbooks that I was using to study in college. So I am, as Julie mentioned, I'm truly excited about the way that it's going to change our understanding of the universe. And in doing so, the next Dr. Nancy Grace Roman sitting in a classroom somewhere next year will be studying our data and hopefully catch the science bug and go on to transform the world in the same way that Dr. Nancy Grace Roman did. I could not be prouder to be part of this project.
I think exploration is important. I think as we explore things, we discover new places. In this case, we're going to be discovering new places remotely with the data that we find from the Nancy Grace Roman Space Telescope. But it is exploration. It's pushing the boundaries of our knowledge in ways that we now can't predict. And we now can't absolutely say what the long-standing legacy is. But I think it's nations that have been successful, have been curious, have explored beyond their boundaries. And what we do with Roman is a very good example of that.
And then Sean Dumagal-Goldman, Director of Astrophysics at NASA.
I said a few minutes ago, when we set out to do these flagships, we set out to do the impossible and then make them routine. And one I didn't mention, but I want to build off of is the coronagraph instrument. That's one that Julie mentioned, doing magic with physics, right? And the technical challenge there is effectively to take a picture of a firefly next to a floodlight from the other side of the country, to go back to the photography example. The reason that's a critical technology for us to take from the impossible to like, oh, we can do it now, is that's a stepping stone to doing the harder problem of taking a picture of that same firefly next to that same floodlight from the other side of the country, but with the firefly off. And now you're seeing the light reflected from the floodlight off the firefly's dark skin back at us. If we can do that second one, which Roman is a major stepping stone towards doing, we'll be able to build our next flagship observatory, the Habitable Worlds Observatory. And that's one that will look at not just stars and galaxies and understand cosmic evolution, but take pictures of planets next to stars and probe those planets for signs of habitability and of life, and really address the question of, are we alone? Are there other inhabited global biospheres like Earth out there? And that's, for me, I love that question.
Thank you all. That summed it up beautifully.
I hope you will join the award-winning About Space Today's coverage this Sunday morning on our YouTube channel beginning at 7 a.m. Eastern Daylight Time, with a launch window opening at 7:20 a.m., weather permitting. And it's for the launch of the Nancy Grace Roman Space Telescope. Don't miss it. And be sure to invite your family and friends to listen in twice monthly. And if you like our reports, be sure to click like, follow, and hit that subscribe button for me. To all our listeners around the globe and here in the U.S., thanks for taking time from your home or from where you work to listen today. I'm David Denault.